Hi guys, I want to share an inquiry that I got this morning from Matthew Day. So he was at a customer measuring a 10mm slot inside a material, and the customer was used to using single element probe, so single or UT technology, and then he wanted to indicate when, I think he meant the back wall gets smaller than the reflection from the actual slot, or he's mentioning 50%. When these both are 50%, that's when he want to indicate and measure this distance either in C scan or B scan. So obviously, as you see here from Matthew's fantastic drawing, that when you go at an area where there's no flaw, then you get a clear back wall, and then when in the middle of the flaw you get a clear indication from the flaw. But in the edge here, then you get some of the sound goes to the back wall, some of the sound goes into the flaw, and you get this area where you're flipping from the back wall being the highest to the flaw reflection being the highest. And in between here, when these are equal, maybe that's where they indicate that the flaw starts. So anyway, I have here, I'm scanning here, this is a flat bottom hole in carbon fiber. And as you can see from the C-scan amplitude, if you watch the A-scan at the same time, if I go in here, then you see in this edge here, then the amplitude goes down quite a bit. And then you see the indication reflection becomes higher. So it's a little bit difficult then to measure exactly where do you exactly measure from if you want to measure the diameter here, or with the circular material. Same here in the B-scan. It's hard to see exactly where to start and stop. So one way of doing this is, of course, if you use the time of flight. It's a very harsh picture, right? And then this is a very brutal way of showing your flaw. If you actually pick up the distance from this yellow here too, then your flaw echo is larger than the back wall echo. So that is something that you can use as a measurement or as a requirement. So then you just do the outer pixel to the outer pixel here, and you get 10mm. So just to make that clear, when the switch is, the time of flight image is much more honest and much more brutal about which reflection is the highest. Is it this back wall one, or is it the flaw one? But Matthew was talking about something with 50%. So let's say I put a 50% threshold here. Then I can enable threshold, show threshold, and then enable threshold, and I put this at, for example, 50%. There's 50%. And of course now you get a huge area in between the back wall and the actual flaw where both of them are lower than 50%. So to measure this could be anything from here to here, which is 8mm, to here to here, which is 12, right? So not very accurate. But if I increase my digital gain until this area is very small, then I get a much more accurate measurement. So I can do here, for example. Now I got just a small area here, which is, these are all under 50%. They should be around 50%, same as here. Then you can draw this line from this area here to this area here. It's just 10.33. So that is a way of measuring what you want to measure, Matthew, but it would be cool to be able to measure this showing the A-scan here at the same time as I was moving this around, because then I could indicate and maybe just click. Here is the start because they are equal in size, and then here is the end of my measurement because then they get the back wall and the flaw reflection becomes the same amplitude. Anyways, that was my tip of the day.